Today, we're diving into a drug that is a truly double-edged sword in medicine. It's called heparin. It's an absolute lifesaver, a guardian against a silent killer. But, it also holds a pretty dangerous secret. So let's unravel the story of this fascinating and vital medication.
I want you to think about this for a second. When you get a cut, your body's ability to form a clot, it's a miracle of biology, right? But what if that exact same life-saving process went rogue? What if it started happening deep inside your veins, when there's no injury at all? What if your body's own defense system literally turned against you?
Well, this internal threat has a name. It's called thrombosis. It's when a blood clot, a thrombus, forms where it absolutely shouldn't, choking off vital blood flow. This right here, this is the villain of our story. And it's a formidable one, capable of causing heart attacks, strokes, and deadly pulmonary embolisms. Okay, so to really get a handle on our hero, heparin, we're going to follow this simple roadmap. We'll kick things off with the basics. What is the stuff and how does it work? Then we'll get into the two main types, where it's used, and of course, the crucial risks. And at the end, we'll wrap it all up with the key takeaways. So let's jump right in. What exactly is this protector, this guardian against unwanted clots? So heparin is what we call a fast-acting anticoagulant, which is just a fancy way of saying blood thinner. But here's the part that might surprise you. It's not some neat synthetic drug cooked up in a lab. Nope. It's actually a complex mix of sugar chains, and its origin is completely natural. It's derived from animal tissues, usually from the intestines of pigs or the lungs of cows. Okay, now this is probably the single most important thing to get about heparin, so let's make it crystal clear. It does not bust up clots that are already there. Think of it less like a dose of Drano for your veins and more like a security guard that stops any more junk from clogging up the pipes. It prevents new clots from forming, and it stops the ones you have from getting any bigger, which gives your body the time it needs to break them down naturally. So how does it actually pull this off? Well, the mechanism is incredibly elegant. I like to call it the supercharger tactic. It's really just a three-step process. First, heparin latches onto a protein that's already floating around in your blood called antithrombin. Then, this binding action supercharges antithrombin, changing its shape to make it a way more potent clot fighter. Finally, this newly empowered complex goes on a mission to neutralize the key construction workers of blood clots, guys like factor XA and thrombin, effectively shutting down the entire clot-building assembly line. And when we say supercharge, we really mean it. Heparin boosts antithrombin's natural clot-fighting power by about 1,000 times. Yeah, 1,000. That's not a small adjustment. That's like trading in your scooter for a rocket ship. And that's how heparin has such a rapid and powerful effect. Now, heparin isn't a one-size-fits-all kind of drug. There are two main versions that act like specialists for different jobs. We have unfractionated heparin, or UFH, and low molecular weight heparin, or LMWH. The big difference between them really just boils down to size. Think of UFH as these long, kind of tangled chains of all different lengths. LMWH, on the other hand, is made by literally chopping up those long UFH chains into shorter, more uniform pieces. And this simple physical difference completely changes how they act in the body. And this is where you can see the trade-offs. UFH's long chains are beasts. They're powerful enough to inhibit both major clotting factors. But that power makes their effect unpredictable, which is why UFH requires constant monitoring in a hospital setting. You need that tight control. LMUH, with its shorter chains, is more selective, making its action incredibly predictable, which is perfect for use outside the hospital. But here's the kicker. In an emergency, UFH can be fully reversed with an antidote. LMUH, only partially. So with these two specialized tools in the medical toolkit, where do we actually see heparin in action? Well, its power makes it a cornerstone of care in so many critical situations. The short answer is, pretty much anywhere a serious blood clot is a major risk. From treating deep vein thrombosis and pulmonary embolisms to managing heart attacks, heparin is essential. It's used to prevent clots after major surgeries like hip replacements, and even to keep medical devices like dialysis machines from clogging up. It really is a workhorse of modern medicine. But as they say, with great power comes great risk. A drug this good at stopping your body from clotting is, you guessed it, a double-edged sword. This one probably won't come as a huge shock. I mean, if you're purposefully messing with a body's ability to form clots, the number one risk is, of course, unwanted bleeding. This can be anything from minor bruising all the way to a life-threatening internal hemorrhage, which is exactly why its use is so carefully managed. But there's a far more bizarre and frankly terrifying side effect: heparin-induced thrombocytopenia, or HIT. And this is where things get truly strange. It's a paradox, a condition where the blood thinner causes catastrophic blood clots. So the big question is, how on earth is that possible? How can the very drug designed to prevent clots trigger the exact emergency it's supposed to stop? Well, the answer lies in a wild case of mistaken identity by your own immune system. So here's the breakdown. In a small number of people, the immune system sees heparin attached to a platelet protein and freaks out, thinking it's an invader. So it creates antibodies to fight it. But these antibodies then go rogue, triggering a massive, uncontrolled activation of platelets all over the body. This sets off a dangerous chain reaction. Platelets get used up, causing the count to drop, and a storm of new life-threatening clots is unleashed. Okay, we have covered a ton of ground. So let's just take a breath and boil this all down to the key points you absolutely need to remember. So here's the cheat sheet. First, heparin prevents clots. It doesn't dissolve them by supercharging your body's own defenses. Second, UFH is the big gun for hospital emergencies. It's powerful, it's reversible, but it needs constant watching. Third, LMWH is the predictable, stable choice, often used for treatment outside the hospital. And finally, always remember the two biggest dangers: bleeding and the bizarre, paradoxical clotting of HIT. And that kind of leaves us with a fascinating question, doesn't it? Heparin, a drug we get from animals, discovered over 100 years ago, is still absolutely essential in our high-tech hospitals. In an age of AI-designed drugs, what does that tell us about the untapped power of the natural world? What other life-saving secrets are still out there, just hiding in plain sight? Thanks for joining our explainer.